Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's webinar titled The Decision Model and Data Quality, Advice from Practitioners, brought to you by Knowledge Partners International, the thought leader in the field of business process and decision modeling, requirements, and change management. I'm Michael Gross, and I will be your host today and begin with a few announcements about our KPI Education Program in 2014. Let me introduce our today's panel. Barbara von Halle will be our moderator today. Barbara is one of the managing partners and founder at Knowledge Partners International, KPI. She is co-inventor of the decision model and co-author of the book, The Decision Model, a business logic framework linking business and technology, published by Taylor and Francis in 2009. She is the fifth recipient of the Outstanding Individual Achievement Award from Data Management International, also known as DEMA. It's the premier organization of data professionals worldwide, which inducted Barbara into its Hall of Fame in 1995. She's an early pioneer in data architecture and business rules, and many of you listened attending presentations and webinars with her in the past. Barbara will engage in a dialogue with our practitioners, Steve Worsham and Ken von Halle. Now about Steve. Steven is a senior business analyst at Sapiens. He has been using the decision model for years in a variety of different project environments, primarily within the mortgage and financial industries. Stephen has experience in leading end-to-end decision modeling projects that incorporate both data acceptance and business decisions within the Sapiens decision software application. Stephen holds a certificate as a KPI decision model practitioner. Ken von Halle is a decision analyst with Knowledge Partners International, helping clients to become self-sufficient in decision modeling. Ken has experience in decision modeling in the areas of banking, mortgage and student loan eligibility, wealth management, data acceptance, and data migration. He had been active in training and collaborated with our technology partner Sapiens at the most recent projects. Ken also holds a degree as a certified decision model practitioner. Today's webinar is based on the article titled The Decision Model and Data Quality, Advice from Practitioners, which was published in Modern Analyst and TDM. With that, I pass the microphone to our moderator, Barbara von Halle. Barbara, good to have you on the webinar today.
Okay, thank you, Michael. I'm very excited that we're able to do a webinar based on data quality and the decision model because it's been a very popular topic of conversation at conferences. So it was nice that we were able to publish an article on it and also to do this webinar as a follow-up. And what I'd like to do is I'd like to start with an interesting timeline here on this page to show the birth and the impact of the decision model to date, because a lot of things have happened in 2013 and 2014. So this timeline shows that in 2009, that was the year that Larry and I introduced the decision model for the first time to the public after we had been testing it out for about 2 to 4 years prior to that. At that time, there was no software. We simply used Visio and Excel. In 2010, the decision model was adopted by a leading financial institution, but still without commercial software, and they still found it advantageous over previous approaches. In 2011, Sapiens developed the enterprise-grade product called Dedsion to support the decision model, which was very exciting for us. And also, as of 2012, the decision model and the software have been adopted by leading global financial institutions around the world. So we've been pretty busy. What's also interesting is in 2013, inspired by the decision model, the OMG Standards Group for IT decided to develop a standard for decision modeling in order to recognize it as a new discipline and a new software marketplace. And they announced a press release in only January of this year, 2014, to talk and introduce their standard. So a lot has happened, and we're sort of right in the middle of everything really picking up very quickly. So what I'd like to do on the next page is I'd like to give you a brief review for several pages here of the decision model for those of you who are not that familiar with it. And for those of you who are familiar with it, it is a brief review. So it's not totally detailed, but it should be of value. And also for your folks to see how you might introduce it to your own organization. So this page may look familiar to most of you. It is how many of us, including myself, captured and managed business rules prior to the decision model. And we would pull them all together in a spreadsheet form like this. We would have different kinds of rules all together in one spreadsheet, different ways to express them, and then we packaged them all up with requirements and turned them over to programmers who developed code from them. And unfortunately, we didn't often keep the text version of the rules up to date. So the code ended up being updated over time, and we lost the source of the business rules. So as you all probably know, this turned out not to be an overly useful approach. So how would such business rules look in the core element of the decision model, which we call a rule family? If you are already familiar with Sapiens decision product, you know a rule family by the name of rule family view, but they are essentially the same thing. So look at the statement at the top of this page. It has 3 conditions with an and leading to a conclusion. The statement says if card lock status type is lost card and account closure lock status is active and an account closure channel is back office, then we are to conclude that account closure is ineligible. So now, look at what this looks like in a rule family table. If you look at the second row in this table, the statement above is included in the second row because the second row checks for card lock status type of either lost card or stolen card, and then the other conditions are the same. So, so you can see from a rule family that the conditions are ANDed together, and down the rows are ORed together. So you can write this as one big paragraph if you wanted to without losing the integrity. And it's also the case that the rule family tables, that's not all we know about them, that they have ands and ors, etc., but that there are principles that make sure they represent the logic in its most minimal form with the maximum logic integrity and in normalized chunks. And so what we've learned so far from this page is that the rule family table is what shows us the details of the logic, but what we wanted was a model. In order to have a model, we need a diagram, we need a picture. And so for that, we create something called a decision model diagram. And those, again, those of you who are familiar with the Sapiens decision product know this diagram as a decision view. In the book, it's called the decision model diagram. So how does this diagram work? In the octagon is the name of the conclusion we are seeking for our decision. So in this case, the conclusion we are seeking is excess alert status. And beneath the octagon is a tablet representing the structure of the rule family table behind it. And at the top of this particular rule family structure is the name of the conclusion as it appears in the octagon. So you can see that it is also excess alert status. But below it are the types of conditions to use in reaching that conclusion. And here we see 2 conditions. We see excess alert balance and product. So behind this tablet is the rule family table with all the rows, with the ands and the ors between the rows, that show us the details of how these conditions actually lead to this conclusion. So let's take a look at that a little bit more. So on this page, we have the rule family table that stands behind it. So how does that diagram correlate to the rule family table? The red arrow shows you that the octagon, or the conclusion in the top of the rule family table, becomes the name of the column under the conclusion heading. And so now you see excess alert status. Now you can take a look at the yellow arrow, shows you that the condition that is called product in the rule family tablet now becomes the name of a condition column, but there is no underline under the name. And the lack of an underline simply means that the values for product come from raw data to compare to the values in that column. Now we see a green arrow that shows you the condition called excess alert balance, and that also appears, well, it appears between the solid and the dotted line in the rule family tablet, but it becomes also a condition, a column heading under the conditions, but this time it's underlined. Underlined here simply means that the value for it does not come from raw data, but it is actually the conclusion in another rule family. So what does this mean? It means that in the diagram, the decision model diagram, under the green rule family tablet in the diagram on this page, we have to grow the branch of logic that will determine excess alert balance. So we will start to tease out the structure of the logic. Eventually, we will have an entire organized set of connected rule families. So let's see what this looks like in the real world. This is a very nice decision model for banking. It was actually done by one of our clients. And notice how much more orderly it looks than the spreadsheet we started with. Notice how the labels, and you could use these in your own presentations, can assist someone in navigating this decision model and understanding exactly what it's doing. Now imagine that each of these tablets has a populated rule family table of conditions added together to reach the conclusion, and that everything is normalized into the smallest possible chunks of logic without losing any logic. I would think that this probably looks a lot nicer than the original spreadsheet. So on this page, I simply wanted to reinforce that no matter how small or how large your decision model diagram is, each of those rule family tablets in that diagram has its own fully populated rule family table. So you see that they are on to the right of you here. And the 15 principles of the decision model are what will find all the errors in those rule family tables long before you actually test this decision model with test data. It will find the errors in the logic. And so that's very valuable and a time saver. And this page points out a significant benefit to creating decision models, because this benefit is what decision models do to your process models. It turns out that when you remove logic from a task box in a process model and put them in a decision model, the whole entire process flow becomes simplified. And specifically, on this page, you see that all of the logic that's in the decision model in the red square on the right-hand side stands behind only one task in the process model. And in the past, a process modeler may have had multiple tasks to represent this logic because there was no separate kind of model to show that logic all in one place. You needed to connect it with process. And so this way, we now have a model that's independent of the process model. And so the process and the decisions are now truly independent of each other. So that gives you an overview of the decision model and how it compares to previous approaches. And I want to move more now into the topic of this webinar, which is on data quality and the decision model. But I want to introduce you first to a new phrase, which we call data acceptance, and how that relates to data quality. So as a data architect, a data professional in my past life, I understand the definition of data quality. It has a standard definition, which is shown in its first bullet on this page. And so data quality means that the data is fit for its intended uses in operations, decision-making, and planning. And specifically, we measure data quality in different sets of categories, such as data completeness, the validity of the data, and consistency, and so on. But in most organizations, and those that I've started in some organizations, the data quality function sits within IT, in which technical users operate very technical software to test the quality of data as that data is stored as technical artifacts in a physical database. And the scope of the fitness of data for data quality functions tends to be across the entire enterprise and its systems. So this was a dilemma for us because the decision model is not aimed at technical audiences. It actually is a product and tool that's used by business people and business analysts. So we use the phrase data acceptance in the rest of this webinar. What we mean by that is that the data acceptance testing is defined by non-technical people, not IT people. They use the decision model, which is a non-technical technique, or a Sapiens decision tool, which is a non-technical tool, and it tests the quality of the input data for its target decision models only. It's not testing it for the entire enterprise's usage, but to make sure that the decision models are using high-quality data to reach their conclusions. So what this means is that data acceptance is testing the quality of the fact types as you folks, as decision modelers, define those fact types in the business glossary. They are not testing the data as it's physically stored, because that would require too much technical expertise. And business people are very comfortable with the glossary. And so the scope of our data fitness for data acceptance is we test it for use in a particular decision model, not for across a whole entire enterprise. And we'll actually show you an example of the difference between what a business person sees as the data that they're checking for data acceptance and what the IT function sees when they perform what's known as formal data quality. So in a nutshell, we are using the phrase data acceptance to essentially mean data quality, all those categories that we talked about, but as done or governed by business people for data model usage. And so you'll see some data quality if you're familiar with that. The categories are similar, but you'll see the technique is quite different. Okay, with that, let's start with questions for our practitioners, and I'll start with Ken. The question for you, Ken, to kick us off is, what is the difference between a business logic decision model and what we're now calling a data acceptance decision model?
Okay, thanks, Barbara. The business logic decision models contain the real-world logic for a business need, whether they are defined internally by the business or externally, for example, through a regulation. Data acceptance decision models are complementary to business logic decision models. The data acceptance decision models take the fact types used in the business logic and test them to make sure they are of acceptable values. This process allows the business logic to execute to the highest degree of accuracy. On the next slide, we will show the difference between business logic decision models and data acceptance decision models as they are found within process. So this process model illustrates the difference between data acceptance and business logic decision models as they are found within process. The data acceptance decision model, shown on the left as a collapsed subtask, precedes the business logic decision model, shown on the right as a collapsed subtask, for it is evaluating the data elements to determine if they are of acceptable enough quality to execute the business logic. As you can see in this process model, if the data is acceptable, we will execute the business logic. If the data is unacceptable, we will end the process. Now, normally in the real world, if it's unacceptable, the data may go through a task or sub-process of tasks to attempt to fix the data and then run through the data acceptance again. If the data is unfixable, however, the process will end.
Okay, thank you, Ken. And so now I have a follow-up question for Stephen. Why should people use the decision model for the data acceptance logic rather than use some other means or some other tools?
Thank you, Barbara. So the first point of using the decision model for data acceptance logic is that it gives the business the control over that data acceptance logic. And it gives it control in a format that's understandable and non-technical, so they can create it and control it. The second is that the deployment of that logic can be deployed to multiple technologies while still containing a single point of truth. So that decision model is the single point of truth, but can be deployed to a variety of different technologies. Finally, there's absolute transparency in the creation, maintenance, and governance of that central decision model repository. So all of your data acceptance decision models are located in a single place that can be controlled by the business. So if we go to the next slide, we'll see an example of this, data acceptance importance and how the decision model affects it. So I want to preclude this by saying that all of this example is done in the Sapiens decision tool, which is an enterprise-level business decision management system. Incorporated within Decision, there is a testing module that allows us to run test cases through our decision models. So the first screenshot we see here is of a business logic decision. So this isn't data acceptance yet. Right now we're just looking at the business logic. And what's just shown up is a test case that I ran on this business logic. So just to quickly describe what we're looking at exactly, on the right side of the screen we see our test inputs. So that those lists of columns are all of the data inputs required to execute this business logic. So we see Florida rider, hurricane zoning change, et cetera, et cetera. So those are all the data inputs. Just to the left of that, we see an expected result and an execution result. So prior to executing this test case, I can say what I think this test case will evaluate to. In this case, I thought it was going to evaluate to automatic renewal process. And then after executing the test case, I can see that the actual result was manual renewal process. So I can see the disconnect between what I expected to happen and what actually happened. And if you look there, you can see highlighted the reason that it came out to a different result is because that Florida rider piece of data is a bad piece of data. So it's using the input outside of domain. And I just chose this name to make it very clear that this is a value that should not be used for Florida rider. It's outside the domain values allowed for the Florida rider input. Now further, if we look at the messages here, we can see that the messages don't provide us any information on this bad data. It's only giving us information on the business logic that was executed. So it's telling us that the reason it's a manual renewal process is because the policy tier was out of bounds and the policy underwriting risk is unacceptable. So it's just giving us business logic messages back and not really explaining that there was an issue with the data. So if we continue with the next slide, we'll just recap this test case here. We see that we're testing whether the Florida rider value of outside of domain is appropriate for this business logic. And we see the error that we got was that the execution result was manual renewal process instead of automatic renewal process. So using Sapiens Decision Tool, we can continue to explore this further and see what exactly happened in this test case. So here we're seeing the rule family where Florida rider is used, and we see the inputs at the top of the screen. So highlighted there is Florida rider is using the input outside of domain. And what we actually find is that this rule family doesn't have a conclusion. So because of that poor data quality with the Florida rider, the policy discount conclusion is null, or meaning no conclusion was found. So if we continue to the next animation, we see that that policy discount of null is used in another rule family, but because of the way the business logic is structured in a completely logical way, that rule family is still able to come up with a conclusion. That conclusion being no in this case. So we can see here by this example that if we had acceptable data, if Florida rider had a value that was acceptable to us, we probably would have come up with a different conclusion for both of these rule families. So this data acceptance error was hidden within the business logic. So it's very important that we capture that. So if we continue on, what we're going to look at now is how the decision model can help capture those data acceptance errors. So here is very small. I'm not expecting anyone to be able to read this decision model, but this is the data acceptance model for that accompanying business logic model. And I decided to run a test case on this as well. So here, again, we see another test case. Remember, now I'm testing the data acceptance decision model, and I can see my input of Florida rider is outside of domain, and that my execution result is unacceptable. So because I'm using a bad piece of data, it's giving me an execution result saying that your data is unacceptable. And now my messages can actually be specific to say that only the values of on and off are acceptable for Florida rider. So this is a message that the business can actually use in order to improve their data and get a more accurate result for their business logic. So the benefits of this are that it provides the business with complete control over the data acceptance requirements that the business needs, and that's on a per decision model basis. So for this particular business logic, the business needs these specific data acceptance criteria. It's very clear and easy to interpret the logic. So we can see here that one, the data acceptance logic was very simple in that decision model, and that the results are very clear to understand. It's supported by the TDM principles, so this enforces that the logic is created appropriately. And finally, we get some actionable results in a business-friendly language. So we can actually do something with this unacceptable result. So we might have to go through the process model to determine that there's an additional step required to fix the data, or just in the process altogether.
Okay, thank you, Steve. So what you've told us is that we really need to check the quality of the input data if we're going to use that data in decision models. And you also told us that the decision model has benefits for actually putting that logic into decision model format instead of in a different format. And so now I want to ask Ken, why should we separate, I'm assuming we should, the data acceptance decision models from the business logic models? In other words, we're going to have, as he showed us in the process model, we're going to have one model for data acceptance and another decision model for the business logic. Why do we separate those, Ken?
Okay, so separating data acceptance decision models from business logic decision models has many advantages. The first advantage is that separating these two allows the business logic to be directly compared and maintained against the business logic source. This allows for manageability of the business logic asset, as well as allows for traceability directly from the business logic decision model to the business knowledge source. A second advantage is that it increases runtime efficiency by handling unacceptable data before executing the business logic. A third advantage is the ability to reuse business logic decision models without having to repeat the data acceptance for every use. Depending on how the user models the data acceptance, they can pick and choose the business logic that they wish to reuse, as well as pick and choose the data acceptance that complements it.
Okay, so that sounds like some good to separate the data acceptance logic from the business logic. But does that mean that you need to have experience with data architecture or data modeling or anything like that? So Steve, can you tell us what kind of experience do you really need to do the data acceptance decision models?
So the experience that someone needs to do the data acceptance models is not too strenuous. You don't need to have any knowledge or prior experience with data management or data architecture. What you really need to have is some experience in capturing requirements, so being able to understand what the business needs out of the data are, and then also an analytical approach to problem solving and a great attention to detail. So being able to understand what the business needs and how to accomplish that. And we're going to go through another example here to quickly identify why it's not important to have data management experience as much as it is to have business analytics experience. So here in our example, we're looking at a sample driver's license, and we want to focus specifically on a piece of data, the date of birth of this driver. So from a business point of view, a subject matter expert and someone looking at the data acceptance would consider this piece of data called driver birth date. So all we're focused on from a business point of view is how are we using driver birth date, what type of values are we expecting, what format should it be in, are there any restrictions as far as when someone was born or how old or young they are, things like that. From an IT perspective, and when they're looking at data quality, what they're really looking for is something more specific as far as how is the data managed within their databases. So they're looking at maybe a person table and a driver license table and relating those two tables together and making sure that the data within those tables matches just the requirements of those tables. So how we avoid having to have data quality experience is that we perform a data mapping in the decision model. So essentially the business side is only concerned with the driver birth date, and they're just mapping that back to all the work that the IT department has done to ensure that the proper information is relayed to them.
Thank you, Steve. That's a great example. And so what you're saying is a data acceptance person, a business person or a business analyst, what they want to do is make sure that the fact type driver birth date is of high enough quality to use in a corresponding decision model where they're going to check the driver birth date. So I presume that means you want to check the 4 data quality categories against those business-friendly fact types. So can you describe those categories for us?
Certainly, and we use the same DQ categories in data acceptance as we do in traditional data quality. So the first one that we're going to look at is called Completeness, and all this is checking is whether the data is populated or unpopulated, so whether it's there or not. And this also includes conditionally required fact types. So if we only require a piece of data under certain conditions, we can include that in our data acceptance checks. The next one is called Domain Validity. And this one relates back to the example I walked through earlier in that the value for a fact type must be within the allowed values for that fact type. The third one is called Value Validity, and this is made up of mainly 2 parts, reasonableness and accuracy. So this determines whether the fact type values are a reasonable and accurate value to be using in the business context. Finally, we have Consistency. And this is checking for the required relationships among the fact types being used by the business. So whether the 2 values of 2 different fact types make sense in conjunction with each other. Here we're seeing an example of the process. So here's the process model that we showed earlier. And we're looking at, in that first picture on top, that farthest to the left box for the data acceptance logic. And all we've done is just broken out that collapsed subprocess into its expanded process. So that's what that dotted line indicates. So below, we're looking at the expanded process for data acceptance. So we've discussed briefly how we might want to separate the data acceptance decision models into multiple decision models. And here's that perfect example here, as we see that each of those data quality categories gets its own decision model. And that way we're able to check completely and in the most atomic fashion, in the simplest way, for each of the data quality logic for the entire business case. So if we continue on, we'll see an example of a couple of these decision models. So here we're looking at the first decision model in our process. This is the completeness model, and we've just put together a very simple example here. So there's only one rule family here, and this rule family contains 3 fact types. So we see that we're looking for driver cell phone, driver video game, and driver other hands-free device. So these are our inputs, and all we're checking here is whether that data is populated or not populated. So do we have a value or do we not have a value for that fact type? And so we can see that the first row tells us that if all 3 of these are populated, if we have a value for all 3 of these fact types, then our data acceptance is complete. So it passes this data acceptance check. Conversely, however, if any of them are not populated, then we're going to fail this data acceptance check. We're going to mark it as data acceptance incomplete. So the next example we're going to look at is for domain validity. Again, very similar, and another very basic example here. In this case, we're looking at the same 3 fact types, but in this time, we're checking for something different. We're not looking just for whether the fact type is populated or not populated. We're looking at what the actual value is and determining whether it's an allowed value for that particular fact type. So we see that in the case for driver cell phone, we want to make sure that the value we're using is either in use or not in use. It's one of those 2 fact types, one of those 2 values for this fact type. Same thing goes for driver video game and driver other hands-free device. All we're doing is checking to make sure that the value that we have as input is an allowed value for that specific fact type. And of course, if we have any unallowed values, anything outside of the domain for those fact types, we're going to mark it as invalid and fail this data acceptance check.
Okay, thank you, Steve. And so now we understand that we probably want a separate decision model for each one of those categories. So do we just take all the data elements or all the fact types and put them all into the completeness, into one completeness model, or do we somehow want to break them up into even smaller completeness models, for example, or validity models? And for that, I'll ask Ken. How can you describe for us the best way to model those acceptance categories looking at the data?
Okay, well, it completely depends on the size of the business logic decision models that you're dealing with. So if you have small business logic decision models, like we just saw in the previous example where we only had 3 fact types, there will most likely be one decision model for each data acceptance category. This means that one data acceptance decision model for completeness, one for domain validity, one for valid values, and one for consistency. The data acceptance decision model should in turn be simple and small in structure. Now, it gets a little difficult when the business logic decision models are large or there are many business logic decision models for which there needs to be data acceptance. When this is the case, we prefer to break down the fact types of the business logic decision models into related groups. Each group will be one decision model, resulting in multiple decision models per data acceptance category. The same groupings should be used for each data acceptance category as necessary. Using this method, you may have 4 models for completeness, 4 models for domain validity, but maybe you don't need to repeat each category for valid values and consistency. So 2 decision models for valid values and 1 for consistency. You will find that completeness and domain validity are oftentimes very similar in structure, where valid values and consistency are not, as they are usually the catch-all. To determine how to group the data, it's best to use a schema that already exists. For example, MISMO for mortgage or Accord for insurance. If one is not available, you can also use business concepts. For example, driver information, license information, passenger information, etc. Or you can use your internal data structure if nothing else is available.
Okay, thank you, Ken. Stephen, one more question regarding how many decision models for data acceptance. It sounds like you can have quite a lot of decision models, and you can have just a few depending on how you bundle your fact types together and how you bundle your different categories together. So can you clarify when to create separate decision models for different data acceptance categories and when to bundle them all together into one data acceptance decision model?
Certainly, Barbara. So the best way to look at this is to really focus on what are the different characteristics of each approach. So first, we'll take a look at the properties of the all-in-one decision model. So a single decision model that encompasses all four data quality categories. In order to pull this off, you really need to have a small number of data points, so very few inputs for your business logic. There should be few to no interdependencies, because as soon as you start having interdependencies among the fact types, the complexity really starts to multiply. Finally, you should not be concerned about sequential execution in this approach, because we're looking at only a single decision model, and of course the decision model is declarative and there's no sequence inherent within the decision model. For the separate decision models, and this is the more common approach, what typically occurs is that there are many data points, so you're checking a large number of inputs. There may be several to many interdependencies among the fact types, so that complexity could be great. There could be greater complexity within the conditions, so maybe you have conditionally required fact types, etc. And then, of course, you can find a potential for grouping those similar data points, as Ken mentioned in the previous slide. So now let's talk about the benefits and the weaknesses of each approach. So for the all-in-one decision model, the strength really is that it's a very simplified process model. The implementation is very straightforward. You're only executing a single decision model. The weaknesses here, though, are that one decision model can become highly complex and very unmanageable. There's a great loss of transparency whenever you're trying to bundle everything into a single decision model. You reduce the flexibility of that decision model as well as the reusability. So because it's very specific in nature and there's a lot of complexity within that model and how the fact types are interacting, it may not be as reusable as the separate models. Finally, there's a greater degree of difficulty in the maintenance of these decision models. So anytime a change request comes in, it requires a much deeper analytical approach for dissecting what's going on in that single decision model as opposed to the more atomic and normalized multiple decision models. So now let's look at the separate decision model strengths. First is that they're very transparent and specific in nature. So just by reading the title of the decision model, you can tell what exactly it's looking at and what exactly it's talking about. So it's very straightforward. The logic is typically much more simplified. So because we've broken it down to this very specific piece that we're looking at, the logic can be much more simple. There's greater reusability, so these groupings and these particular categories can be reused across the enterprise in other business logic cases. And then, of course, natural data groups tend to form when this occurs. So you can more clearly see which fact types are related to each other, which ones have those interdependencies. So during the process of creating these, those natural data groups tend to form on their own. The weaknesses here really involve the process. The process is going to be much more complex because you're going to be managing multiple decision models within that process. So you need to make sure that the process is really in line and that the execution knows what it's doing very specifically. Additionally, there's a greater number of decision models to manage, although as we mentioned earlier, the decision models are much more simple and easier to interpret. So the management of them individually is easier, but there are a larger number of them.
Okay, thank you, Steve. And so now we've talked a little bit about how many decision models for data acceptance, whether how to group our fact types together, how to group together the different categories. But what's really interesting is what exactly should data acceptance decision models do? Ken had alluded to the fact that sometimes they can correct or attempt to correct the data. And so I'm going to open this up for Ken. What did you mean by that? What exactly are the options of what data acceptance decision models can do?
Okay. Well, data acceptance decision models will, of course, go through the 4 categories, but there are 2 approaches to using those categories. So the 2 main types of approaches that we have are reactive and proactive. Now, reactive data acceptance decision models are the standard data acceptance decision models. These models will execute through all the data acceptance logic and display what the invalid data is to the user. If there are any data errors after leaving the data acceptance task, the business logic task will not be executed. Instead, measures will be taken to fix the data and then run through the data acceptance decision models again until all the data has been fixed. If the data cannot be fixed, the process will end. However, we also have proactive data acceptance decision models, which will still display the invalid values to the user, but instead of ending the process or fixing the data, the invalid values will be replaced by acceptable assumption values and then go on to execute the business logic anyway. So what the user is left with is the conclusion of the business logic based on reported assumptions. This can be valuable to business when they don't have all the data yet, but would like to see if the data that they do have is valid going forward. So the user doesn't have to commit to one of these approaches. Maybe some processes can benefit from the proactive replacement approach, where other processes will benefit more from the attempting to fix the invalid data first before executing the business logic. It is up to the business to decide which approach is ideal.
Okay, that's, I think, one of the exciting parts of doing data acceptance logic is being creative in what you do when your decision model finds errors in terms of what the business needs are. Moving to a little lighter topic here, a question for you, Stephen, is can you share with us, because I know you have a lot of experience doing data acceptance and very simply and very complex, can you share with us the biggest surprise in creating data acceptance decision models so far?
Sure thing, and really I wanted to point out two surprises here that I found. The first is that the data acceptance decision models can become complex very quickly. So when you initially think about the data DQ categories we've talked about, it seems like, oh, populated versus not populated, whether it's in the domain, those are so simple, it shouldn't be difficult to create these. But once you start looking at the interdependencies between the fact types in your data acceptance models, it can really lead to a large number of rule families quickly. Luckily, with the decision model, these complexities are exposed in a manageable way. But it was surprising to see that it only takes a couple of these interdependencies to really start spurring some complexity within the decision model. Now the second surprise, and kind of related, is that larger models don't necessarily mean more complexity. And what I mean by this is that a large number of fact types could yield a very large decision model, depending on how you structure it. But it doesn't mean there's a lot of complexity there, because there might not be many of those interdependencies. So you could be checking against 100 fact types, but if they're all independent of each other, the logic is going to be extremely simple.
Okay, thank you. And a similar question for Ken. Can you share with us what you found to be the most sophisticated or interesting data acceptance decision models?
Cool. Yeah, sure. So I'll start with sophisticated, and this kind of goes off one of the topics we covered already, where if you really try to pile in all the data quality dimensions into a single data acceptance decision model, that decision model is going to become very complex and sophisticated very quickly. So this is one of the major reasons, along with manageability and reusability, why our best practices stress separating the acceptance decision models into as many granular pieces as needed by the business. So for the most interesting, this is the topic that I covered last, we have the proactive data acceptance decision models, which are the assumption-based data acceptance decision models. So the decision model was not created to handle this kind of functionality. However, through testing and exploration of the decision model's principles, both internally with our clients, both internally and with our clients, we've uncovered its ability to handle data acceptance in this way. So the more practice you get with the decision model methodology, the more you test the boundaries of its capabilities, and it's always fun to see what useful functionality you can uncover.
Okay. Thank you for both of you guys, but I want to wrap up with a question for Steve. I would presume that most of the folks who are listening to the webinar they may be new to the decision model, but even if they have experience with the decision model, they may not be using it for data acceptance or data quality logic. This is just not the logic that comes to the surface when you start doing decision modeling for different projects. So do you have any words of advice, Steve, for people who have not done any acceptance decision models but find this very interesting and possibly needed in their current project? What advice would you give them?
Certainly, and this is the typical steps I go through for any data acceptance approach. The first thing that we want to do is to break up the data acceptance logic into those 3 or 4 different data quality categories that we've been talking about. So first, understand that you're going to be focusing on different decision models. We may discover later that we can combine some of the more simple ones, but for the first step, you want to go ahead and break them into those 3 or 4 different categories depending on the business's needs. Next, start with the completeness decision model. Completeness is certainly the most simple of the data quality categories, and we should just be checking whether each of the fact types that we need are populated or not populated. And you may get some experience to a little bit more complexity if you have any conditionally required fact types, but it should still be a relatively simple decision model for you to get started with. The next thing you want to do is really focus on the domain validity decision model. And as we mentioned earlier, domain validity and completeness are usually pretty similar in their structure and their logic. So this is just going to validate that each of the values that we have are acceptable values for those fact types. So again, we just want to start with the more simplistic decision models and work our way up. Next, we'll move on to a more difficult category, which is consistency. And this decision model is going to validate the relationships among the fact types. So depending on how complex your decision logic is and what the needs of the business are, consistency could get pretty complicated pretty quickly. So just an example would be that if our value for state is New Jersey, then we want to go ahead and check that the zip code value that we have is a valid New Jersey zip code. Finally, we want to go ahead and try to do the value validity decision models. So these are going to check for accuracy and reasonableness, and really we kind of consider value validity as a catch-all for the rest of the any other DQ checks that we might want to perform. So that's why we usually do this last, is we can say, well, we'll check for the accuracy and the reasonableness and anything else that we might not have covered so far. During this entire process, you might notice that the decision models are becoming very large and they're difficult to manage, and the complexity is just getting really, really great. So what you want to start doing is looking for those opportunities to group the fact types into related groupings. This way we can create separate decision models based on those groupings, so that we're really simplifying the decision models. We're not losing any of the logic, but we're simplifying the decision models into something that's more manageable, it's more transparent, it's easier to understand for both the business and the analyst that's creating the decision models.
Okay, well that brings us to the end of the formal part of this webinar, and we do have enough time for 2 questions. So I'm going to give one question that came in to Ken and one to Steve. And Ken, the question is, even though the skills needed to create data acceptance decision models are the same as those to create the regular business logic decision models, would it be advisable for a decision modeler to be an apprentice on a data acceptance decision model before they do one on their own? Is there something special about them that they might rather see it first and then do it?
Yeah, well, that's a very interesting question. So the skills are the same, but the thinking is different. So for starters, I mean, you're testing conditions leading to conclusions about DQ categories. So it may help to have seen some of these DQ categories ahead of time, so you can understand how to test for them. And it's also necessary to understand some logic pieces that are specific to data acceptance logic, such as testing the populated characteristic of a fact type, or even knowing what the domain values are. So if you'll be creating like proactive data acceptance decision models, for example, it can be tricky to replace missing or incorrect data values using decision model logic. So it's definitely better to have seen this done before and to have an apprenticeship.
Okay, thanks, Ken. And then Steve, someone wants to know, they know that they always do a process model when they're doing a business logic or business decision model. And you folks showed some process models that included the data acceptance logic. So do you always need to create the process model before creating your data acceptance decision models?
It's a great question, Barbara. So the simple answer is yes. We always want to start with the process model. So the first requirements you're going to gather are, what exactly do we want to do with the data acceptance failures? Are we going to end if we don't have certain populated characteristics? Are we going to continue anyway and try to run the logic no matter what? So understanding that process is going to make it easier for you to understand what the requirements around the specific data acceptance logic would be. So there may be some cases where if you're testing for completeness, If you don't have the values that you need to have, you're going to go ahead and end the process and try to fix the data manually, or maybe you want to try to run it through and see what happens no matter what. Additionally, there may be some other sequences that are important within the process, so testing for valid domain values before you test whether the values are consistent with each other or whether they're reasonable and accurate. So the process model is going to make the understanding of these sequences and dependencies much more tangible.
Okay, thank you. So it sounds like those people who are familiar with and have experience with process models and decision models basically follow their instincts, do basically the same kinds of things when doing the data acceptance logic models. So with that, that brings to a close our formal part of the webinar, and I will turn it back over to Michael Gross.
Thank you very much, Barbara. This was an excellent presentation. In-depth presentation of practitioners. I would like to close our session today with our announcements. This is a repeat of the beginning of the webinar. Just want to point out that we have now a webinar scheduled for every second Thursday in a month. This is the fourth one. The next one is with the Sapiens decision. It is an exchange with one of the product experts and us, and you will see how Sapiens decision is a great fit for decision modeling and how it has been incorporated in this application. Then we have an innovation webinar with Barbara von Halle, where she will introduce the event model to you. That's a new model, and it's just at the early stage, and therefore we will provide you this webinar as under the umbrella of our innovation webinar series. Now, I also would like to point out that every third Tuesday in a month, we have our Decision Modeling Essentials online class. This is a class that stretches over 3 days. It starts at 9:30 a.m. and ends at 12:30 p.m. Eastern Daylight Savings Time. So that allows you to still continue to cover some areas in work, but also attend the webinar from the comfort of your home. You will be able to gain 9 IIBA PUs or CDUs for this training. And if you are interested in finding out what are the costs and how to register, please visit our website, kpiusa.com. I repeat, our website is www.kpiusa.com. At our events page there, you can see what kind of events are coming up and when the training is scheduled, and you can also register there. If you are a LinkedIn member, please sign up to our LinkedIn group. The LinkedIn group is called The Decision Model, and we have a second one that's called Decision Model, The Decision Model News. The first one is a closed group, and it provides you a platform to interact with other experts and practitioners that are using the decision model, that have questions or answers about different aspects of it. So we would be very happy to welcome you as a member of that group, and also as an attendee of our next webinar. If you liked it, please tell your friends and colleagues, and we will make this webinar available as the others as a webinar recording. You can find all the recordings at our download center. Just go at our website, and then you can download. It's not a download, but you can stream our webinars. Thank you so much for attending. This brings us to the end, and we're looking forward to seeing you again. Bye-bye.